Okay, so the main thing is I want to talk about last night's work real quick and see if there's any issues. All right, so what do we have? Anybody have any questions? Yeah. 40. So what's an issue? So A was okay, right? Because it says show that there's a right triangle with sides A, B, and C, right? So we can just do 3 squared plus 4 squared equals 5 squared. You with me? But I also, I'm going to show you something that I think what they meant by this. All right. So it says here, if we're going to complete the table, M is greater than N, and A equals M squared minus N squared, and B equals 2MN. All right. So if M is 3 and A is 1, I'm sorry, N is 1. So that'd be 9 minus 1. You agree with that? What?
Yes.
So that's 8, right? What is B? B is 2 times Mn. So what would that be? 2 times 3 times 1. 6. Right? And C is equal to M squared plus N squared. So what's 9 plus 1? There you have it. You with me on that? Now I understand now what their directions are for A, so I'm going to work you on that too. But that's clear now, right? You're just plugging those numbers into the different formulas. You with me? So now what I want to do is just so I can show you just what they meant by A. And then C is equal to M squared plus N squared. So let's just do 3 and 2 now. All right. So A is 3 squared minus 4. So that's 5, right? And then B is equal to 2 times 3 times 2, which is what? 12. And we know from our triples then 5, 12, the other one should be what? 13, right? Or C equals 3 squared plus 2 squared. 9 plus 4 is 13, which is what we concluded. You with me on that? All right, so let's just do the next one. A would be 16 minus 1, right? We can do this in our head now, right? Now that I see the patterns. 16 minus 1 is 15. And then 4 times 2 times 1 is 8. And then if you remember our triple, it would have been what? 8, 15, 17. Thank you. All right. Or 4 squared plus 1. All right. So we have A is 16 minus 4, which is 12. 2 times 4 times 2 is 16. And then 16 plus 4 is 20. Everybody okay with that? And then 4 squared minus 3 squared is 16 minus 9, which is 7. And then 4 times 3 times 2 is 24. And then 25. And there was our other triple. All right. So again, guys, I think that was pretty hard. All right. But if you understand the pattern, that's going to work out. Now, I'm going to show you why it works out now, because I understand their question for A better now that I see that. I think that should have been question A. And then B should have been A. All right. So what does that mean? So we know that A squared plus B squared equals C squared. Do you agree with this, guys? So now what is A? right? And B is 2mn, and C is that. Well, wait a minute now. Squared on. Let me think about that for a minute. All right, I wanna so that was just kind of plugging the numbers in for the table, right? All right, now let's see what C says. Find the triple. Oh, and by the way, does everybody see this? Is how they they're finding the triples, right? 3, 4, 5, right? 6, 8, 10 is a multiple of 3, 4, 5, but 5, 12, 13, 8, 15, 17, 7, 24, 25. All right. Now, let's just do the last one. What was the last one? 5 squared minus 1, 24. And then 2 times 5 times 1 is 10. And then the last one is 26. And that's also a multiple of 5, 12, 13. All right, so now we want to try to find the triple that corresponds to 25 squared, which is 625. Was anybody able to figure that out? Tell me, Harrison. Well, how is, but okay, so I appreciate that very much, but 3, 4, 5 wouldn't be the right answer, right? Because we want this to be 25. Right, there you go, 15, 20, and 25. Does that make sense? All right, so that was a little bit, yeah.
I think the 7, 24, 25 works also.
Yeah, that's right. That's good. Yep, you could have done either one of those, I think. All right, so what I'm going to do is put it on pause real quick, and then I'm going to show you something really important that I meant to do yesterday, but we'll resume. And if you want to kind of follow along, if you want to draw it out for me, that's fine. If you just want to really pay attention so you understand, that's fine also. I love my iPad because I can make good little demonstrations. The first thing I'm trying to do is make a square. All right, that looks like a pretty good square. All right, now the next thing what I'm going to do is I'm going to draw another square in this square, but I'm going to shrink it down. I'm going to turn it so it fits exactly in, tangent to all the sides. I'm going to turn it a little bit more. Oh, come on. All right, so that's pretty good. All right, make it a little bit bigger. All right, that's perfect. Okay, so now everybody take a quick look at that, please. All right, now I want to call, there's 2 squares there. Does everybody agree? All right, so this square I'm going to call C. This is C, this is C, and this is C. All right. Now, this right here is a square, but I'm going to call this A, I'm going to call this B. All right. Now, because that's a square and this is a square, can somebody tell me what they think this distance has to be right there? I thought it was obvious, but obviously not. What is that distance? A. And what is this distance? B. What's this distance? And so on. And that is exactly true. All right, does everybody see that? All right, that has to be the same. Now, again, what is the area of the small square? Say it, come on. C squared is the area of the small square. Now, what's the area of this triangle right here, guys? No, 1/2 AB, right? It's 1/2 AB. Now, how many of those triangles are there? 4. Does everybody see that? So that's the area of the big square. Does everybody agree with that? Anybody have any problems with that? Oh, come on, guys, this is exciting. I don't know how you're not like pumped up for this. Equals. Now, how would I calculate the area of the big square? With the outer.
A plus B squared.
You are amazing. Thank you. All right. So these represent the sum of the interior, right? And this is just the product of length times width of the big square. Does everybody agree with that? With what?
Oh, how did you get A plus B squared?
I'm talking about the big square, Harrison.
Yeah.
How would I find the area of a square?
Oh, okay, never mind.
Right? The area of a square is length times width or side squared. And the side of the square is A plus B. Does everybody agree with that? Everybody agree? Okay, so now C squared plus what's 4 times half AB? 2AB equals. Now, if I expand A plus B squared, that's supposed to be what? A squared from last year plus 2AB plus B squared. Does that make any sense? Do I need to show you how to expand A plus B squared again?
Yes.
Okay, so just as a quick refresher, and this is good for your upcoming tests when you have to take them. A times A is A squared. Remember, we did smiley faces. AB plus AB is 2AB plus B squared. Is everybody comfortable with that now? Does everybody remember that? Okay. And so now what can I do to both sides? Cancel the 2AB. So now you just did the oldest proof known. C squared equals A squared plus B squared. You should. That's the oldest known proof. Okay, so let's slow down just a little bit. This area is what? How do you find the area of a square? Right? What's this area? What's the formula for area of a triangle? And how many of them are there? Right? And half of 4 is 2. And we expand A plus B because that's the outer square. Right? A plus B is the length of this side of the big square. All right. So again, that's simple, simple, simple. All right. Not a difficult thing to prove. All right. Now what we're going to do is we're going to develop the formulas. And again, this is crucial for high school. All right. And again, for some strange reason, all right, this is a difficult thing. All right. I don't understand it, but it is. All right. So now, again, if you are more comfortable watching, I'm okay with that. All right. If you know it's harder for you to get things, all right, writing and, listening, then just pay attention. All right. And ask me a question. All right. So what I'm going to do now is I'm going to draw another square and we're going to derive the formula for a 45, 45, 90 triangle. So that's a square. Does everybody agree with that? Okay. So now I'm going to draw this diagonal. This is still 90 degrees. Everybody agree with this? Does everybody understand this is a 45 degree? This is 45 degrees, right? So this length right here is X. I don't know what that is. So this over here is what? X. So I don't know what the hypotenuse is. Everybody with me? So I'm going to calculate the hypotenuse. And how would I do that? We would just use the Pythagorean theorem. So we say x squared plus x squared equals c squared. So I agree with that. So 2x squared equals c squared. So I agree with that. Now I take the square root of both sides. So the hypotenuse is the square root of 2 times whatever the side length is. And again, I'm not kidding. I don't understand the difficulty here. All right, so that's a simple proof for 45, 45, 90 triangles. The hypotenuse is always the side of the square times what? Times radical 2. That's how easy that is. Anybody have any objections to that? All right, now how is that helping me? So I'm just going to come down here to question number 1. All right. So someone please tell me what this side length is. 8. What's the hypotenuse? 8 radical 2. That's how simple this is. That's how simple. All right, and like I said, for whatever reason, this is like a difficult thing for kids. Now, how I remembered is this. Listen to me. The leg is smaller than the hypotenuse. Does everybody agree? So if I'm going from the leg to the hypotenuse, I need it to get bigger. So I'm going to do what? Multiply by radical 2. If I'm going from the hypotenuse to the leg, I have to do what? Divide by radical 2 because it's getting smaller. All right, so that's if you don't understand the proof. For me personally, it was never an issue because I understood the proof, right? Hypotenuse to leg, you're getting smaller, right? So you would divide. From a leg to hypotenuse, you're getting what? Bigger, so you would multiply. The other way we told kids to remember is that there are 2 different angles involved. If there are 2 different angles involved, then it would be a what? Radical 2. On the 30, 60, 90, guess what radical is going to be involved? 3. Exactly, because there's 3 different angles. All right, but we'll get to that in a second. All right, so look at number 2. What is x? 3. Embarrassingly easy. All right. Number 3, what is x? 4 radical 2. Number 4. A little bit harder now. So what is it? Someone.
18 over radical 2.
Thank you, sir. 18 divided by radical 2. But are we allowed to have radical 2 in the denominator? No, so we have to rationalize from last year. Last year, we learned to rationalize the denominator. That means the denominator right now is irrational. Is everybody hearing me? So if I want to change it from irrational to rational, I multiply the top and bottom by what? Yes. So multiply by radical 2, I get 18 radical 2 over what? 2. And what happens to the 18 and the 2? To what?
9 radical 2.
So that's what that is, 9 radical 2. And obviously the other side is also what? 9 radical 2. Simple, simple, simple. All right, so number 5, just to make sure we're clear, what's this going to be? Yes, but let's just do the math, even though that's brilliant.
So 16 over radical 2.
16 over radical 2 is perfect. All right, now, those of you guys who can see math, right, you should be able to say, okay, I'm going to multiply the top and bottom by radical 2. It's going to be 16 radical 2 over 2, which is just what? 8 radical 2. If you don't know that, then you have to do the work. The rest of us don't. You do. And then eventually, if you do it enough, you'll see the pattern. All right? Anybody have any questions? I told you it's super easy. Super easy. But like I said, this is a nightmare for most kids. So number 6, obvious answer is now what? 24. Okay, so now we're going to try to do it without the picture. If the hypotenuse is 12, what's the other length? Right, 6 radical 2. You're allowed to just write 6 radical 2 if you know. Now, who doesn't know that? And I don't mind. Everybody knows. Hypotenuse to leg, you divide by radical 2. And then you just do the math. Is everybody agreeing with me? All right. So if the hypotenuse is 25, oh, wait a minute, determine the length. Oh yeah, it does say. So what would it be?
12 and a half radical 2.
Yeah, I like that, but we leave it as fractions.
25 radical 2.
Yes, but you're exactly right. If you said that, that would be correct also. We just don't do decimals. All right. And if the leg is 14, the hypotenuse would be what? Yeah, guys, like I said, it's embarrassingly easy. All right, so now let's go back to the top of the page. All right, because now I know you might be running out of room, so I'm sorry. All right, so now I need to prove to you the 30, 60, 90. All right, and like I said, I don't understand the difficulty here. And they're formulas, but some kids forget the formulas. So you need to learn how to figure things out. All right. So what I'm going to draw now is I'm going to try to draw an equilateral triangle. Like everybody try to draw an equilateral triangle best you can. All right. So because this is an equilateral triangle, then the side length I'm going to call is C. Why do you think I'm going to call it C? Because I'm going to draw in the what? The altitude. Now, first of all, can someone tell me what the angle measures are right off the bat? I need to erase this. Say it again. Thank you. What are the angle measures? 60. That's exactly correct. So 60, 60. Now, I'm not going to draw a 60 up top because I'm going to draw the altitude. And we learned this last semester that when you draw the altitude of an equilateral triangle, what does that do to the angle? Bisects it. So now this angle here now is what? 30. Does everybody agree? So this is now what they call the what? The 30, 60, 90 triangle. Right? And what I mean by that is this triangle is what they're referring to. Not the equilateral triangle, but this is how they figured it out. All right, that's the 30, 60, 90 triangle. Does everybody agree? Now, can anybody tell me this side right here was what? What is that side length? C, right? Because it's equilateral. So now I need someone to be brave and tell me what this length is. Say it again. You might as well give it a shot. The worst can be is wrong. What do you think it is? Half a C, right? Or we're going to call it C over 2. That wasn't that hard, right? We learned that. Everybody okay with that? And now we're missing B. Does everybody agree? I don't know what that is. Everybody happy with that? Now, does everybody agree that's a right triangle? And we just proved the Pythagorean theorem. So we know that C over 2 squared plus B squared equals what? C squared. So bear with me on this. Okay, so now what's C over 2 squared? Come on, now we got to do our math. What's C over 2 squared? C. Come on, guys. I'm asking for a simple question. C over 2 squared, what is that? C squared over, thank you very much. Come on, guys. Plus B squared equals C squared. All right, now here's where for some strange reason, kids give me a hard time about not knowing this. So I'm going to write something and don't go, what? How'd you do that? Just think about it for a minute. I want everybody to understand that B squared is equal to 3C squared over 4, or 3/4 C squared. All right, and when you think you know how I got that, tell me. How did I get to that step right there? So what you're telling me is you don't know what c squared minus 1/4 c squared is. What's 1 minus 1/4? That's how I got the 3/4 c squared. All right, so that's a little bit harder to see, but you should see, okay, that makes sense now. So everybody agree with that? Hello? Everybody okay with that? Come on, guys. All right, now you're not gonna have to reproduce this, so don't, it's just nice to know. All right. So now I just take the square root of both sides, square root of both sides. Do we know what the square root of 3 is? Radical 3, thank you. All right. What's the square root of c squared? What's the square root of 4? 2. So that's where you come up with this relationship. All right. So b is equal to square root of 3 over 2 times the hypotenuse. All right. That's the relationship. All right. In a 30, 60, 90 triangle. So I want everybody to understand this. 30-degree side is always half the hypotenuse. The 60-degree side is half the hypotenuse times what? Radical 3. All right. That's all that is. It's a very simple process. All right. And I got lots of examples for you. All right. So that's really, really, really important information. All right. So now we're going to come back over here. So now I'm going to try to make myself clear. So this 1/2 is opposite the 30, correct? So the hypotenuse is always twice as big. So what's the hypotenuse? 1. Now to go from the 30-degree to the 60-degree, you just multiply by radical 3. So y is square root of 3 over 2. That's how simple. All right. So now's the time you can make yourself a note. So I'm on number 11. So notice this is a 30. So who's paying attention? Who can tell me what y is? 16. All right. It's a pattern. It's all it is a pattern. And you guys are great at patterns. So this should be no issue. So y is how much?
16.
And x is how much? 8 radical 3. That's how simple. All right. All right, number 12. So what is x? 11 over 2. Thank you. And then what's y? Thank you, sir. 11 radical 3 over 2. Now, before we go any further, does everybody understand if you're not seeing the pattern, right, it'd be better to tell me now, right? It'd be better to tell me now. Yes.
Can you explain how you got y?
I just multiplied the 30-degree side by radical 3.
Okay.
So now watch what I do for kids. 90 to 30, I divide by 2. 30 to 60, I multiply by radical 3.
Okay.
Now watch, if I go the other direction now, if I'm going from 30 to 90, what do I do?
So you just multiply by 3?
Multiply by 2.
I mean 2.
I know that. And then from 60 to 30, what do I do?
You divide by?
Right. So this is what I always tell kids, if you're having trouble, this is what you would write down at the top of your paper. That's the rule. That's the rule. Now notice you only have to know one of them, right? Because if you go from 90 to 30 and you divide by 2, that means from 30 to 90, I would multiply by 2. Notice again what I'm also telling you. From 90 to 30, I'm getting smaller, so I'd have to what? Divide. From 30 to 60, I'm getting what? Bigger, so I'd have to do what? That's how easy it is. Now, there are how many different angles in this triangle? So we're going to use a radical 3. In the other triangle, there were 2 different angles, so we used a radical 2. Now, that's for people who are not understanding math. I really prefer you not to do that, but some people like to simplify processes, which is perfectly fine with me. All right, that's how you would memorize it, in my opinion. All right, I don't have it memorized. All right, I want you to understand exactly what I'm doing. All right, so hopefully that helps. What? From the 30 to the hypotenuse, what do I do? Well, you need to fix your notes. From the 30 to the 90, what do we do? That's it. Now look up, because I'm trying to show you something. Look up at my picture. This, once I understood this, it came from a 30, 60, 90, or it came from an equilateral triangle. I just figured it out every time. I hated memorizing things. So now do you understand what I'm saying, right? Look right here. Do you see this 30? Right? Directly opposite the 30, what's the side length? That's an angle. Yes, it's half. Right? That's how I knew that. Right? Opposite 30 is half the hypotenuse. All right. And if you want, you can write that down over and over. Opposite 30 is half the hypotenuse. All right. So now let's look at this guy over here. So again, I need to make this clear. The 9 radical 3 corresponds to what angle? 60, because we talked last semester about the angle and the opposite side are related. So this is the 60. So the 30 would be what? Which would be measure how much? 9. And y is what? Is 18. All right, now some of you don't get frustrated. All right. You good? You sure? Positive. I'm gonna let you do the next one. All right. Wait, what? No, I never say from the 60 to the hypotenuse. Never will I do that. Ever. Never. I never go from the 60 to the hypotenuse. I go 60 to what? 30 and 30 to 90. All right. You never do that. All right. There's an extra step involved. That's why. Okay. All right. Marin, what is 12 related to? I'm asking you a question. 12 is to what angle? 60. So I need to go to the 30. How do I go from the 60 to the 30? Divide by what? You just didn't, you said divide by 3. No, we don't divide by 3. We divide by what? Say it. Radical 3. Divide by radical 3. So this is 12 divided by radical 3. Hold up. Which gives me, multiply the top and bottom by square root of 3. So that'd be 12 radical 3 over 3, which is 4 radical 3. So then the hypotenuse is what? 8 radical 3. All right, so you got to finish up, guys. You got to finish up. Now, you guys do your best. All right, some of the word problems are a little tricky, so we'll spend a little extra time on Monday reviewing, because tomorrow, for some reason, they decided to do something, whatever. Nice. Why would they do that? I don't know.
No, but I mean, like, okay, where we at now?